Okay, we're going to do the basic chain rule first and then the general chain rule. So this comes after the other rule. So last one we did was the product rule. So the basic chain rule, I'm going to state it and then we're going to roughly prove it. And then we're going to and look at some examples as well. Okay, so if this was the function, so the function was some function to the power n, then the derivative, it's going to look just like the power rule with an extra step. Okay, so the derivative is take the power down in front, reduce the power by 1, but then you're going to multiply it by the derivative of the inside function. Okay, so you're really just taking the derivative of this with respect to g of x instead of just x, the variable is now g, and then taking the derivative of g with respect to x. Okay, so an example here. So f of x equals 3x squared minus 4x to the 7, all to the 7. You don't want to multiply this out. This is going to take a long time. You could, but what if that power was, or that exponent was 305? You wouldn't want to expand that out. It would be too long. So there's a shorter way of doing that, and that's using this chain rule. So the chain rule says take that power, so the 7, bring it down in front, reduce it by 1, so that would become a 6, and then multiply by the derivative of the inside function, the derivative of that polynomial. Okay, so here's what you get. So the 7 comes down in front, reduce that by 6, don't change this, just reduce that by 6, then multiply it by the derivative of this function on the inside. So the inside, the g of x, is 3x squared minus 4x. Okay, so the derivative of that, g primed, is 6x minus 4 by using the power rule. Okay, another example. If you had 7x cubed minus x squared plus 1 square rooted, well, that's the same as having a power of 1/2. So we can use that same rule again. Okay, so bring the power down in front, which is 1/2. Reduce it by 1. So remember, 1/2 minus 1 is negative 1/2. Keep that inside function the same, and then multiply by the derivative of the inside, which is going to be 21x squared minus 2x. Okay, so that's the chain rule. And here's how we basically say the chain rule. Take the derivative of the outside function with respect to the inside function, and multiply by the derivative of the inside function. So the derivative of the outside times the derivative of the inside is usually what we say. Okay, so we're going to try and prove this. Well, we're going to start off with some basics here. So just let's start off with g of x to the power 2. See how we can get that one going. Okay, if f of x is some function squared, then we can just use the product rule. Okay, it's the product of two functions. They just happen to be the same. So the product rule says the derivative of the first times the second plus the first times the derivative of the second, which is this. So the derivative of the first times the second plus the first times the derivative of the second. They're the same thing, just written in a different order. So you've got two of them. Okay, so the derivative of g of x to the power 2 is 2 times g of x times g primed of x. So bring the power down, reduce it by 1, so that's just a 1 there, and then multiply by the derivative of the inside function, which is g primed of x. Let's take a look at when the power is 3. Okay, so if the power is 3, same thing, but we already know the derivative of g of x all squared, so we can make it that product. Okay, so the derivative of the first, well, we know this from the previous one. The derivative of the first is 2g of x times g primed of x. So I'm going to write that in. 2g of x times g primed of x times the second function is the product rule, plus the first one, which is g of x squared, times the derivative of the second. Simplify that. You've got 2g of x squared g prime of x and 1g of x squared g prime of x. Together you got 3 of them. So what did we do? Bring the power down, reduce it by 1, multiply by the derivative of the inside. Okay, so that's for 2. Now we could keep going, but if we do one more, you'll get the idea. Okay, so I'm just going to do one more, g of x to the 4, and you'll see that it just has to continue on in this way. And you might already see it already. So g of x to the 4 equals g of x cubed. We know what the derivative of that is, so times g of x. So the derivative of g of x cubed is this. Okay? So the derivative of g of x cubed is 3g of x squared, g prime of x. And then we're going to multiply by the other one, so that's the product rule, plus g of x cubed times the derivative of the second. Simplify that, we get 3 and 1 of the same thing. Put it together, and we've got this. So it's good to try this on your own to see if you can get it to work out. And again, we brought the power down, reduced it by 1, multiplied by the derivative of the inside. Okay. Continuing this way, you would get the chain rule that I mentioned at the beginning. Okay, so if f of x equals g of x to the power n, bring the n down, and reduce by 1 multiplied by the derivative of the inside function. One more example. What if you had something like this? 3 over this function, 4x cubed plus 7x minus 1 all to the 5. Okay? Well, we can bring that up so that it looks like this. So that becomes a negative exponent. And that's just a constant in front, so we don't have to worry about that too much. So the derivative, well, bring the negative 5 down, multiply it by negative 3, gives you negative 15. Keep the function the same on the inside, and reduce the negative 5 by 1. So the tendency here would be going to negative 4, but you're subtracting 1, which makes it negative 6. And then multiply by the derivative of the inside, which is 12x plus 7. Put this back in the form that it was originally in, and you've got this, so it's all positive powers. Okay, so that is the chain rule. I call it the power rule chain rule, so the basic chain rule. Now, overall, the chain rule, so nothing has really changed, but really what we're doing there is we're composing two functions. So we've got x to the n function and g of x. Now here, what if the outside function isn't x to the n? What if it's just some unknown function? So g, circle k, so that's composition of functions, is g of k of x. Same rule applies. Okay, we get the derivative of the outside function, but with respect to k. So g of g by d of k times d of k by d of x. Okay, and let's look at an example for this one. So let's let g of x equal x to the 4, k of x equal 3x squared minus 5x. This is the power rule chain rule. Okay, so we've got this. We know how to do this. Bring the 4 down, reduce by 1, multiply by the derivative of the inside. But if we lay it out here, okay, so g of k, so following this rule here, we want d of g of k with respect to k. So g of k is the variable, which is going to be k to the 4, not x to the 4. dg by dk is 4k cubed. And then k of x is the inside function, and dk by dx is 6x minus 5. Now we plug that in. Okay, so here's our rule. df by dx is dg by dk, dk by dx. Okay, which is what we had up here. Derivative of the outside function, which is g, times the derivative of the inside function, which is k. Write them in. 4k cubed. Easy as that. Times 6x minus 5. But we want to express it in terms of x. So k of x is 3x squared minus 5x. So 4 times 3x squared minus 5x cubed times 6x minus 5. Now this works based on our previous rule. Remember, we bring the 4 down in front, reduce it by 1, multiply by the derivative of the inside. Okay. What if we did it another way around though? What if we looked at k of g of x? Okay. So the functions are the same, but we're now looking at k of g of x. So k of g of x, the derivative is going to be dk by dg, the derivative of the outside with respect to the inside, times the derivative of the inside. Okay? So k of g of x equals 3g squared minus 5g. Okay? 3g squared minus 5g, plugging in g. The derivative is going to be 6g minus 5. And then for g of x, we get this. Okay? It's not as easy to see what this function looks like. We would have to actually plug it in, k of g of x. What does that look like? Well, we'd have to plug it in and see what happens. Okay? So, df by dx is 6g minus 5 times 4x cubed. Plug the g in. G is x to the fourth. We've got that. Okay? You could try another one where g of x is that and k of x is this. Not nice at all. Okay? And I'll leave the solution here for you. Take a look at and try to analyze. Okay? That's it for the chain rule.